Hello, you are all welcome to today's lesson. In this lesson, we are going to learn about signal transmission medium and, to be precise, network transmission medium. After this lesson, you will be able to discuss and distinguish between the operations of the various network transmission media, including coaxial cables, twisted pair cables, satellite communication, fiber optics, radio waves, and even microwave transmission. To begin, let's take a quick recap on the previous lesson. In the previous lesson, we continued with the part 2 of our IP addressing topic. We learnt about the Class D and E IP address. We learnt that the Class D IP address ranges from 224 to 239 and are mainly used for multicasting. Through this, we discussed briefly the modes of data transmission and gave some real-world examples of multicasting, which include live video streaming and video on demand. We spoke briefly about the Class E IP address. We saw that this address ranges from 240 to 255 and are reserved for research purpose by the Internet Engineering Task Force, popularly known as IETF. We then spoke about loopback address. We said that this address ranges from 127.0.0.0 to 127.255.255.255 and are mainly used for network troubleshooting and testing. We saw that the most commonly used loopback address is 127.0.0.1 and is also called the local host. In addition, we learnt about link local addresses. We saw that this address ranges from 169.254.0.0 through 169.254.255.255. This address allows you to have network connectivity when a DHCP address could not be properly obtained. They are also known as a PIPA, also known as Automatic Private Address or Stateless IP Auto Configuration Address. We again discussed what CIDR means and how we can subnet and assign IP address using CIDR notation technique. Lastly, we discussed about who manages and controls the assignment of public IP addresses globally. Starting with today's lesson, let's see what data transmission medium means. Data transmission medium refers to the means or channel through which data is transmitted from one point to the other. These media usually serves as a mediator between the transmitting point, technically known as transmitter or the TX, and the receiving point, also technically known as the receiver or the RX. In data communication, transmission medium works like a physical path between the sender and the receiver. The data or signal being transmitted behaves differently depending on the transmission medium. In a copper cable network, the bits are mainly in the form of electrical signals, whereas in a fiber network, the bits are mainly in the form of light pulses. We are going to delve deeper in the various transmission medium and to know their various properties, characteristics, and operations. This brings us to the types of transmission media. 1. Guided media. 2. Unguided media. We can further group these under two main classifications. These include wired media and wireless media. Under the wired media, we have all the cable types, which include twisted pair cable, coaxial cable, and fiber optic cable. Under the wireless media, we have all the wireless communication media such as radio wave, microwave, and infrared. Examples of these wireless media technologies include Wi-Fi, satellite communication, cellular networks, and Bluetooth. Now, delving deeper, let's start with the twisted pair cable under the wired transmission media. The twisted pair cables have pairs of insulated copper wires twisted together like this. These cables transmit data through electrical signals sent over pairs of wires. The twisting technique helps to reduce electromagnetic interference during data transmission. Twisted pair cables are extensively used in Ethernet networks, telephone lines, and mostly in local area networks, LANs. Twisted pair cables come in various types, each designed for specific applications and performance levels. Now, let's see some types of twisted pair cables. 1. Unshielded twisted pair, also known as UTP cable. 2. Shielded twisted pair, also called STP cable. Taken these one after the other, the UTP cables consist of pairs of copper wires twisted together within a plastic insulating sheath. The UTP cables are commonly used in Ethernet networks, telephone lines, and most residential and small business networks. These can also be further categorized into several classes, including Cat5e, Cat6, Cat6a, and Cat7. Each of these categories offers progressively higher bandwidth and better performance. Now, talking about the shielded twisted pair or the STP cable, these cables have additional shielding around the twisted pairs, typically made of foil or a combination of foil and braided shielding. STP cables are used in environments with high levels of electromagnetic interference, such as industrial settings or places with lots of electronic equipment. The STP cables are also categorized into various classes, similar to UTP cables. These include Cat6a FTP, Cat7s/FTP, F/UTP, SF/UTP, U/UTP. Now, one may ask, how can one read and distinguish between these cable types? The first letters indicate the type of overall shield, while the latter letters indicate the type of shielding on each pair and the balanced element. In these examples, the S/FTP means there is an overall screened element and a foiled around the twisted pair cables. The F/UTP means their cable consists of 4 unshielded twisted pairs. However, it contains an outer foil shield. The SF/UTP means there is an overall braid foil and screen shield elements around the unshielded twisted pair. The U/UTP means there is no overall shield and the twisted pair is unshielded. Another question you may be asking is, what does the foil shield do in these cable types? The foil shield acts as a barrier, preventing electromagnetic interference and radio frequency interference from coupling onto the twisted pairs from adjacent cables. In effect, it reflects the noise or interference from lights, machinery, and other sources of electromagnetic interference, as well as radio frequency interference from cell phones and wireless access points. In addition, the foil shield prevents data signals from leaking out of the cable. So, these are some categories of the twisted pair cable we can talk about. This cable type is terminated with a pin called registered Jack 45, popularly known as RJ45, for Ethernet connection, or registered Jack 11 pin, also called RJ11, for telephone lines. We shall discuss how these terminations are done in later lessons. The next transmission medium we will talk about is the coaxial cable. Coaxial cables consist of a single copper or copper-coated steel wire that carries radio frequency signals. A dielectric insulator, often made of plastic, surrounds the wire. This keeps a constant distance between the center conductor and metallic braided shield. The metal shield, made of woven copper, aluminum, or other metals, wraps around the insulator. This helps protect the signal from electromagnetic interference. The cable is finally wrapped with an outer jacket. Therefore, Coaxial can be placed near other electronic equipment without any issues. Coaxial cables are commonly used in cable television networks and broadband internet connections. Now, let's look at some types of coaxial cables. Coaxial cables are of different types. We can categorize them under two main groups. These include 1. Radio guide or RG coaxial cable. 2. Land mobile radio or LMR coaxial cable. The RG coaxial cable is commonly used for cable television and satellite television installations. The LMR coaxial cables are specialized category of coaxial cables designed for use in wireless communication systems, particularly in radio frequency and microwave applications. Each of these categories has other varieties and types based on their specifications and performance characteristics. Under the RG category we have RG6, RG8, RG11, RG58, RG59, RG213 and RG174. The RG number refers to the cable's diameter. However, they vary in measurements. Generally, a higher RG number means a thinner central conductor or copper wire, and vice versa. Let's look at some common applications of the RG cable types. The RG6 is used in a wide variety of residential and commercial applications, including cable television, home internet, and more. The RG8 is used in audio control rooms, radio stations, and external radio antennas. RG11 is used for cable TV, HDTV, TV antennas, and video distribution. It is suitable for very long distances in large commercial installations. The RG58 coax cable is best used for CCTV, audio-video, and other low-frequency applications. They are flexible and easy to install as compared to RG6 and RG11. But they are not meant for long distances. RG59 coaxial cable is an older and thinner type of cable that was commonly used for analog cable TV and early satellite TV installations. It has higher signal loss compared to RG6, making it less suitable for long-distance and high-definition video. RG213 coaxial cable is similar to RG8 but has a solid dielectric and is more suitable for high-power RF applications. RG174 coaxial cable is small, flexible cable often used for shorter range applications, including GPS antennas, Wi-Fi antennas, and some consumer electronics. Now, talking of the LMR coaxial cables. These coaxial cables are the newer generation of RF coaxial cables. They are used as transmission lines for antennas on missiles, airplanes, satellites, and other communications. These types include LMR 200, LMR 240, LMR 400, LMR 600 and LMR 900. The LMR number is a rough estimate of the cable's thickness. Now, one may ask, how can you identify these cable types? You can do this by looking at the numbers and letters printed on the cable jacket. This tells you everything you need to know. It tells you the type of cable it is, the manufacturer, rating, and more. Choosing the appropriate type and size of coaxial cable depends on your specific application requirements, including frequency range, power levels, and environmental factors. Let's now look at some common connectors for coaxial cables. Coaxial cables use a variety of connectors, depending on the type of cable and the specific application. This include 1. BNC or bayonet nail concealment connectors. These connectors are commonly used in applications such as CCTV installation, radio, and television broadcasting, and some networking equipment. They are known for their quick connect and disconnect mechanism, which involves a bayonet twist lock. Another connector is called N-type connector. They are widely used in RF, radio frequency, applications, including Wi-Fi antennas, cellular antennas, and microwave equipment. They provide a secure threaded connection and are known for their durability and performance at higher frequencies. We also have the SMA or sub-miniature version A connectors. These are common in Wi-Fi routers, antennas, and other wireless communication devices. We can also talk about the F-type connectors. These are commonly used for cable television, satellite TV, and some broadband internet connections. They feature a screw-on connection and are known for their reliability in carrying high-frequency signals. Another connector is called TNC or Threaded Needle-Concealment Connector. These are similar to BNC connectors but have threaded coupling for more secure connections. They are used in RF and microwave applications. We also have the UHF and mini-UHF connectors. These are commonly used in older RF applications, such as ham radio equipment, mobile radios, test equipment, and amateur radio. Another connector is called MMCX or Micro-Miniature Coaxial Connector. These are used in compact devices, such as laptop wireless cards and GPS receivers. The next wired transmission medium we will talk about is the fiber optic cable. Fiber optic cable uses thin strands of glass or plastic fibers to transmit data in the form of light signals. It is a highly efficient and versatile technology for high-speed data communication. It is used in various applications, including telecommunications and data center networking. Delving deeper, let's see the structure of the fiber optic cable. 1. Core. The core is the central part of the fiber where light travels. It is made of high-quality glass or plastic and is designed to allow light to pass through while maintaining its integrity. 2. Cladding. Surrounding the core is the cladding, which is another layer of glass or plastic with a slightly lower refractive index than the core. This difference in refractive indices ensures that light remains trapped within the core through a process called total internal reflection. 3. Buffer coating. A protective buffer coating surrounds the cladding. It is usually made of a durable material like silicone or plastic, providing mechanical protection and additional insulation. 4. Strength members. To reinforce the cable's structure and provide tensile strength, strength members like Kevlar or fiberglass is added. 5. Outer jacket. The outer jacket provides further protection against environmental factors such as moisture, ultraviolet radiation, and physical damage. Let's look at some types of fiber optic cables. Fiber optic cables can be categorized into two main types, each designed to meet specific performance requirements and applications. This include 1. Single-mode fiber, shortly put SMF. This has a small core, typically around 9 micrometers, that allows only a single mode or path for light to travel. This results in minimal dispersion and excellent signal quality over long distances. Single-mode fiber is commonly used for long-distance telecommunications, internet backbones, and high-speed data transmission in data centers. 2. Multi-mode fiber, shortly put MMF. This has a larger core, typically 50 or 62.5 micrometers, that allows multiple modes or paths for light to travel. This results in more dispersion and limits the cable's maximum distance for high-speed data transmission. Multi-mode fiber is often used for shorter distance applications within buildings, data centers, and local area networks, LANs. Each of these cable types has other subcategories. Single-mode fiber is further categorized under two specifications: OS1 and OS2. OS1 is a standard for indoor single-mode fiber optic cables. It is designed for use in controlled environments where there is limited exposure to environmental factors like moisture and physical stress. They are typically used over distances not greater than 6 miles and support a maximum throughput of 10 gigabits per second. OS2 or optical single-mode 2 cables are used for both indoor and outdoor applications. They are used for long-distance telecommunications, connections between buildings, and undersea cable installations. The multimode fiber can also be further categorized under 5 distinct types. 1. OM1 or Optical Multimode 1. This is one of the oldest specifications for multimode fiber. It has a core size of 62.5 micrometers and is typically used for short-distance applications such as LANs and data center connections. 2. OM2 or Optical Multimode 2. OM2 is another older specification with a core size of 50 micrometers. It gives better performance as compared to OM1 for short-distance data transmission. 3. OM3 or Optical Multimode 3. This also has a 50 micrometers core size, like OM2, but it is designed to support higher data rates over longer distances. 4. OM4 or Optical Multimode 4 is an enhanced version of OM3 with the same core size of 50 micrometers, but better bandwidth and performance. It supports 10 gigabit Ethernet, 40 gigabit Ethernet, and 100 gigabit Ethernet over longer distances. 5. OM5 or Optical Multimode 5. The OM5, also known as wideband multimode fiber, is a newer specification with a 50 micrometer core size. Is ideal for data center applications that require high-speed transmission using short wavelength division multiplexing technology. To end today's lesson, let's finally look at some common connectors for fiber optic cables. Fiber optic cables use various types of connectors, and the choice of connector depends on the specific application, equipment, and fiber optic cable type being used. Here are some common fiber optic connectors. 1. ST connector or straight tip connector. The ST connector features a round, bayonet-style coupling mechanism with a straight ferrule. It is used for both multimode and single-mode fiber optic cables. 2. SC connector or subscriber connector or standard connector. The SC connector has a square-shaped, snap-in coupling mechanism and a ceramic ferrule. It is also used for both single-mode and multi-mode fiber optic cables. 3. LC connector or lucent connector or little connector. The LC connector is a smaller, high-density connector with a snap-in coupling mechanism and a ceramic ferrule. It is used for both single-mode and multi-mode fiber optic cables. 4. FC connector or ferrule connector. The FC connector features a screw-on coupling mechanism with a ceramic ferrule. It is commonly used for both single-mode and multi-mode fiber optic cables. 5. MTRJ connector or mechanical transfer register jack. The MTRJ connector is a duplex connector with a small form factor, featuring 2 fibers in a single housing. It has a push-pull latching mechanism. We will end today's lesson here. I believe you have understood the various applications and the operations of the wired network transmission media under the guided media. We shall continue with the wireless transmission media in our next lesson. Thank you for watching. Please subscribe and share to encourage us to do more. See you in the next lesson.